Right, so to figure out how our chemicals are going to bond, we'll start off first with the Lewis dot structure. So just some things to remember. We're talking about the electrons. The electrons are the most important part. The electrons do all the work. And in this case, it's not even all the electrons. We really only care about the valence electrons. So we'll say really only the valence electrons, which you'll remember from the last section is the outermost shell. And we can determine how many valence electrons based on the column that something is in. So what we can start doing to identify how our elements are going to combine is to start drawing these Lewis dot structures of our individual elements. And so, for example, this whole column, we'll just pick one of them at random. We'll just pick the first one, beryllium. So what we do is we draw a Be, and then we know that that has 2 valence electrons, so we draw that as 2 dots. Note that we don't pair up the dots, similar to how we fill up orbitals, right? And then in the third column, right, you can pick another one there, maybe aluminum. That one's going to have 3. So we'll put 3 dots by themselves. After that is carbon, or just the fourth column, carbon is a representative of that. We can draw 4 individual dots. And then after that, we have to start pairing them up. So for example, over here, let's go to sulfur. That one has 6 valence electrons. So we do 1, 2, 3, 4. And now that we've used up all 4 sides, we have to start pairing up 5, 6. And then if we think about what our elements at the end of the day want to be, they all kind of want to be these noble gases. So let's take an example from there. Let's say argon. 1, 2, 3, 4, 5, 6, 7, 8. So this one right here, argon, has a filled valence shell. Which is very stable. Right? It's very low energy, and it's generally what things want to achieve. They want to have a filled valence shell, which for most elements is going to be 8 valence electrons. The exception, of course, are hydrogen and helium. They only have the 1s orbital, so they only want 2 electrons. So for example, we draw helium like that and hydrogen like that because they only have the 1s orbital, and then thus they only want 2 valence electrons. So as we were saying, that the atoms will interact to become more stable. And again, when we're talking about becoming more stable, the way that they become more stable is to have a filled outer shell. Which we call the octet rule, because most atoms want a 8 electrons to fill their outer shell. Of course, there are exceptions as always. So, right, they can do this in different ways. So for example, we have potassium. Potassium has 1 valence electron. The way that it can become more stable is to have a filled outer shell. So in the case of potassium, it can actually lose that 1 electron. And then you can think of this as an empty outer shell, but really it's a filled outer shell because the shell before it is now filled, right? So something like potassium would want to just lose that electron to have that filled outer shell. Something like chlorine is 1 electron short, and so it'll want to gain an extra electron somehow in order to have a filled outer shell.